Section 2.3, Functions and Math Models. In this section, we'll be looking at different kinds of functions that we'll be seeing and investigating later in this course. Mathematical models, the primary goal is to show you how math, in particular calculus, can be used to solve real-world problems, such as arising from the world of business, social life, and physical sciences. So in the future, you'll see problems that involve mostly a lot of business questions. On page 75 in your textbook, you will see a list of various examples and this little flowchart. Okay, so global warming, Social Security Trust Fund, etc., etc. You'll see how you take a real-world problem, formulate it into a math model, solve it using algebra, calculus, etc., interpret, test it, see if it makes sense. Okay, so that's a nice little way of depicting what we're going to do. Okay, so before we get to all that, let's talk about the various functions. We have already seen polynomial functions, polyfunctions, and polynomial functions basically have nice terms. So if you have a function of this form, f of x equals an x to the n plus an minus 1 x to the n minus 1, etc., plus a2x squared plus a1x plus a naught, where all of these exponents are positive integers. They could be 0, and these are the coefficients. Now the general form looks kind of weird, so for example, instead of an you could have 3, and then here this could be 3x to the 5 minus 2x to the 4th plus 3x cubed minus 7x squared minus 8x plus 10. So this is a polynomial where all the exponents are nice. If you have any terms here that have a fraction or a negative value, it is not a polynomial. Other functions that you'll see in this class will be radical functions, radical with square roots, etc., cube roots. So if you have something like the square root of x minus 8, that would be a radical function, and rational functions. So rational functions, for example, if you have 2x minus 1 over x plus 8, that would be a rational function. Alright, as far as applications go, the business applications, the math model that you'll see over and over in this course, we'll be using the cost function, c of x, capital C of x. We had seen this at the end of 2.2. Cost function is fixed cost plus variable cost. So the fixed cost is what it takes to run the company without any product being manufactured, so like utilities and other stuff. Variable cost is the cost to make each item. Revenue function, revenue is all the money coming in, which is going to include the cost. So this revenue is not the same as profit. So revenue is, let's say you sell an item for a certain price, then it's price times the amount of that object you sell. Okay, so how many, let's say you're selling pens, and you sell 10 pens for 5 cents each. So it's the cost 5 times the price times the number of pens. So this would be price, lowercase p, price times the quantity. Okay, so little p is the unit price, price for each item. Finally, capital P is profit. Okay, profit is revenue, all the money coming in from here, take away the cost. Okay, so let's label all this. This is the total cost function, this is the total revenue function, and this is the profit function. Other examples that we will see here will be things like the supply and demand. We'll get to that as we're doing some problems out of the worksheet. So in the document on WebAssign, go ahead and find the appropriate worksheet and we'll get started. 2.3 worksheet. So this first question is going back to the function idea. Determine whether the given function defines y as a linear function of x. If so, write it in the form y equals mx plus b. Linear is when the polynomial is of degree 1. And in this case, the degree is 1, so it is linear. So I'm going to state that first. It is linear. And then we need to write it in this form, meaning we need to solve for y. So I'm going to add 2x to both sides. I'm just going to recopy the question here so we can see what I'm doing. So add 2x and add 2x to both sides. So you have 3y left here. I'm going to write the 2x in the front and minus 1 at the end, and then divide everything by 3. And I get y equals 2/3 x minus 1/3. So we answer the question. We wrote the equation in the form y equals mx plus b. For the next question, this is not linear since you have a square root. Okay, so not linear. And since it isn't linear, we don't need to go ahead and do the next part. The next question says, determine whether the given function is a polynomial function, a rational function, or some other function. State the degree if it is a polynomial function. So the first one, it's not polynomial since you have x at the bottom. It's a ratio of two polynomials, which makes it rational. So since it's rational, we stop, because if it's only a polynomial, can we do the degree part of it? Okay, next question. You have 3x times x squared minus 1 raised to 5. Now, I would prefer to not multiply this out 5 times. It would take a long time. But it is easy to see that all the powers are going to be nice whole numbers, so this is indeed a polynomial. Now, the degree of a polynomial is the highest exponent in the polynomial, the highest power. So here, it might appear at first that we need to multiply this out to see what the highest exponent is. But like I said earlier, that would take a long time. Rather, it would be better for us to see if we can think. If I had to multiply this out 5 times, I'd have x to the 10th power, and then there's an x over here, so that will make it 11. So the degree is 11. Okay, so that would be 5 times 2 is 10, and then 1 is 11. Okay, moving on to exponents, applications. Here we have a video production company is planning to produce an instructional videotape. This is an old problem. Videos, we don't really use those very much at all. The producer estimates that it'll cost $84,000, and I have in bold font, fixed cost, to shoot the video, and $15 per unit, that's the variable cost, to copy and distribute the tape. The wholesale price of the tape is $50 per unit. That's revenue per tape. Part A, write the cost function. So we need C of x to produce the tape. It's a typo. Assuming that x units are produced. So, as we saw in the notes, cost is fixed cost. That's $84,000 plus variable cost, which is $15 per unit. So it's 15x. We're making x tapes. So that's part A. Revenue function, R of x, is price times quantity, lowercase p, which is $50 is the price, so it's 50 times x. Now notice that this is lowercase, whereas profit function is going to be uppercase, and we saw that earlier, it's revenue minus cost. So that's 50x minus, now let's see if I can do this without making a mistake. You might notice here that this is revenue minus cost, and this should really have parentheses around it because it has two terms. Or if you were to see it in advance, you can distribute the negative right away. So it's minus 15x. So let's combine like terms. 50 minus 10 is 40, minus another 5, 35x minus 84,000. So this is the simplified form of the profit. When will the company break even? Break even meaning the profit is 0. Okay, so profit is 0, or revenue is the same as cost. So let's set this to be 0. 35x minus 84,000 equals 0. Add 84,000 to both sides. Divide by 35. And let's see, how many units should be produced for the company to break even? So 84,000 divided by 35, and I'm getting 2400 units. Alright, oops, here's the work. I didn't realize the camera wasn't under it or above it. I hope it makes sense. Next page, we have another application. This is talking about solar energy. More and more businesses and homeowners are installing solar panels on their roofs to draw energy from the sun's rays. According to the U.S. Department of Energy, the solar cell kilowatt hour use in the U.S. is projected to be given by that polynomial, where 0t takes on values between 0 and 8. In year t, where t equals 0 is 2000. What was the projected solar cell used in the U.S. for 2006, 2008? So if 0 corresponds to 2000, then 6 must correspond to the year 2006. So all we have to do is plug in 6 for t. So it's 0.73 times 6 squared plus 15.8 times 6 plus 2.7. And I'm going to use the calculator here to figure that out. 0.73 times 6 squared. Oops. Plus 15.8 times 6 plus 2.7, and I'm getting 123.78, and that would be the answer, the units of the answer. It's the solar kilowatt hours in millions, so it's million kilowatt hours. This is an abbreviation for kilowatt hours. Now we need to repeat this for the year 2008, so t equals 8, which is 2008, so we need to find s at 8. Now rather than typing it all over on your calculator, if you push second enter and just go and change all the 6 to 8s, then you can do it quickly. So I have 175.82 million kilowatt hours. So as you can see, that has increased in the span of 2 years. It would be interesting to see what it is today. For the next problem, we're looking at demand equations, and some economic model discussion is in your textbook on page 81. So if you don't remember your econ facts, you can go and read this really quickly. The demand curve, this is X is the demand, the number of quantities, quantity available, and that's the price. So as the price goes down, the units increase, but as the price goes up, the number of units sold demanded gets small. That makes sense. You also have the supply curve. That's a competitive market where the producer is as he makes more, he wants the price to go higher so he or she can sell more of the item. Of course, when you want to make this so that the demand and the supply have an equilibrium, that's why we have something called the equilibrium point, where the two intersect. So right here on the next page you have the graph of where supply and demand meet. That's the equilibrium quantity. Alright, so let's take a look at the worksheet. You have a demand equation, P equals negative x squared plus 36. X is the quantity and P is a unit price. The question says to sketch the demand curve. Now we typically only need the first quadrant for these problems. And so this is 36 minus x squared. X squared is a parabola with a negative, it's flipped down. So if this is 36, this would be a rough graph, okay? And when you plug in 6 there, you get negative 36 plus 36 is 0. Now I'm going to use our calculator and see how this works. Adjust our window, negative x squared plus 36. Window x can go from 0 to 10, scale of 1, 0 to how about 40, scale of 4. Let's try that. That's a nice graph. And this point right here, if I push trace and type in 6, that's right there as I predicted. So the demand is, this is the demand curve. X goes here, P goes here. Now the next question is, determine the quantity demanded when the unit price is set as $11. Unit price is P, P is 11. The equation is there, P is negative x squared plus 36, so 11 equals that, and we need to solve this equation. I'm going to add x squared to this side, and I'm going to subtract 11 here. So I have x squared equals, subtract 11 from both sides, and you get 25. So x is plus or minus the square root of 25, which is 5. Now the negative value doesn't make sense because this is a quantity and it's in units of thousand, so you're going to say 5,000 units. So if 5,000 units are, or I should say 5,000 units are demanded if the price is $11. You could have done this problem graphically. Since you already have the graph on your calculator, you could go and type in 11 here and graph that, and you're looking to see where they meet. So you go to second calc, use the intersect option, and push enter, enter, enter again, and it tells you the intersection is at 5, and there's the 5 we got by hand. Now if you choose to do it on your calculator, the kind of work I would expect to see is the graph. You could draw the graph here, and then this is 11, and then point the intersection and say use the calculator, and got this answer. Okay, so either way is acceptable. Last page. This is a problem where you have supply and demand given to you. The weekly demand and supply equations for Sportsman 5x7 are given by these respectively. Respectively means it's in order. So this is the demand equation, and the second one is the supply equation. P is measured in dollars, X is measured in units of 100. Find the equilibrium quantity price. Now remember that equilibrium occurs when supply and demand meet. So they are the same there. In other words, these two should be equal. So I can take this, P equals this, and put it in this spot. And you may have solved for systems of equations in your algebra class. That's exactly what we're doing here. So you're going to set demand to equal supply. So you have negative 0.1 x squared minus x plus 40 equals 0.1 x squared plus 2x plus 20. And being a quadratic equation, I want a 0 on one side. Since this is negative, I want to move that over, get a 0 on this side. So I'm adding those two, add 0.1 x squared to both sides, which is 0.2 x squared, add x to both sides, so it's 3x, subtract 40 from both sides, that's negative 20. So we have a quadratic equation. A good way to solve this would be to get rid of this decimal. I'm going to multiply both sides by 10. Multiply by 10. 0 times 10 is 0, and that's 2x squared plus 30x minus 200. We can make this easier by dividing by 2. Divide everything by 2. So 0 is x squared plus 15x minus 100. Moving up here, let's see if I can factor this. 100 is 10 times 10, but that's not going to help. Can try 15 times, nope. 25 times 4 isn't going to work. So let's see, it's 25 times 4, or 5 times 5 times 2 times 2. How about 20 times 5? So x plus 20, x minus 5 equals 0. So that gives you negative 100, and 20 minus 5 is 15. So we get two answers. You set this to 0, you get negative 20. Set that to 0, you get 5. Can't be negative, so it's going to be 5, but that's measured in 100, so it's 500 tenths must be sold for equilibrium. You could have done this problem again on your calculator. All you would have had to do was type in the first one. Oops, it's a typo there. Negative 0.1 x squared minus x plus 40 for y1, 0.1 x squared plus 2x plus 20 for x2. I'm going to try a standard window. Zoom 6 is what I pushed, and I don't see anything on this window, and that's because these values were big. So for the y, I'm going to try going up to 50 and see if something shows up. There's demand, there's supply. Use the calc, option 5, push enter 3 times, and there it is. They also meet somewhere down here at the -20, but that doesn't make sense on the question. So if you were to use a calculator, draw a rough graph and explain that you got it on the calculator and write the answer out. Final question in this section. J, that's myself, I wish to have a rectangular garden in my backyard. I have 64 feet of fencing material with which to enclose the garden. I want to use the back of my house as one of the sides of the rectangle. This is the wall, okay, of my house. If x is the width, I want you to find a function f giving the area of the garden in terms of x. And then what is a practical domain? So area of a rectangle is length times width, so it's x times y. But I don't want y to be in the answer, I want only x's. And I also need to use this fact that I have 64 feet of fencing. So 64 covers x and y, 2x plus y. I don't need fencing here. So solve for y. 64 take away 2x equals y. So now that I have y, I can go back here. A would be x times 64 minus 2x. And distribute 64x minus 2x squared. So for part A, I really asked for a function f of x. So f of x, which is the area, is 64x minus 2x squared. That gives us the area. Part B, what is the practical domain? Well, the practical domain, in this case, if it's a polynomial, if there wasn't a story, the domain would be all real numbers. But since it's a real world problem, you know that x can't be negative, but can x be 0? Well, if you had a 0, there'd be no garden. Can x be 32? Because 32 times 2 is 64, minus 64 is 0, again no garden. So we need to look at these two facts. You want x to be greater than 0, but less than 32. Okay, and the way I got that was I quickly in my head did this. I set this to be 0, and I saw that 64 would add 2x over, divide by 2, and you don't want to go past that. For example, if x had been like 33 even, you get a negative part here because you get 64 minus 66, that would be negative. So that would be the practical domain of this question. Alright, that's the end of this section. Try the homework. Let me know if you have questions.